Hello all, today we will be looking at exercise 5H, which is solving quadratic equations by completing a square. So there isn't really anything new in this section, it's just tying together a couple of previous exercises, completing the square to factorize and then using the null factor law to solve. So we've actually completed a couple of these style of questions in the previous exercise, so hopefully it shouldn't be too new. We will throw in one little extra bit, which is tunes needs to update. We will be throwing in using a form of completing the square called the turning point form and using a shortcut, which means we get to avoid using the null factor law. Both of them will give us the same answer though. So let's, as a quick review, we're going to factorize these by completing the square. So our key term is this 6, we halve it, then square it. So we go 6, we halve it, and then we square it. That's 6 on 2 is 3, then squared is 9, so we're going to get x squared plus 9 minus 9 plus 6, always doing the addition of our special number first. That will then give us x 3 all squared, and then negative 9 plus 6, that will be negative 3. We can then write that as x minus root of 3 squared. Ooh. Now we have the difference of perfect squares, so we can write this as x minus 3 minus root 3, x minus 3 plus root 3, and we are factorized. Okay, this one here, our magic number is 2, so we halve it, and then we square it. 2 on 2 is 1, squared is 1, so we get x squared minus 2x plus 1 minus 19 gives us x minus 1 all squared minus 20, and that will give us 20. Let's write that in that squared. Now root 20 is the same as root 4 by 5 is the same as 2 root 5. So let's write it like that. Squared. So now we have the difference of perfect squares. We get x minus 1 minus 2 root 5 bracket x minus 1 plus 2 root 5. Now, this is just a review of completing the square. In the previous video, we've already looked at all of this. So this is a bit of review. It's the next slide that is going to be what's new in this topic. So if you're not sure how to use this completing the square, you need to go back and look at the previous videos. Okay, so solving for x. So in these cases, we weren't solving, we were just asked to factorize, but we know that if we were solving these and we let it equal to 0, we can use the null factor law and let this term equal to 0, or this term can equal to 0. We know that from null factor law, we know that from a previous video. If that's something new, again, go back and look at the previous video. But there is a this is showing a full example of looking at exercise B here. So we had x minus 2x minus 19, add the 1, subtract the 1 here, minus the 19. We get in this form, okay, difference of perfect squares, we can go like that. And we get in this form, we simplify our surds here to here, okay, and it's equal to 0. So from the null factor law, we can write it's either the first set of brackets equal to 0 or the second set of brackets equal to 0, and then we can solve for x. So we get x is equal to 1 plus 2 root 5, or x is equal to 1 minus 2 root 5. Okay. Now, up here, and you may have seen this before in exercise 2e, something called turning point form. Okay, what turning point form is, and we'll go to here to this slide. Okay, as I said, exercise 5, you may have seen the phrase turning point form. This becomes really important in future work, especially in your graphing. Because what is turning point form? Well, turning point form is the same as, okay, x minus h all squared plus k, where hk is the turning point of your parabola. So in this case, if I have a parabola, the turning point is this little spot here, okay? That's the turning point where it changes from going down to going up. So in this case we had, and the key thing here is to notice we have a subtraction sign here and a positive sign for the k. So in this case our h is actually positive 1 because we've got negative 1. So the h value itself is positive 1. And then our k is equal to, because we have a positive sign here, our k is actually negative 20. So this graph, our turning point is down here somewhere at 1, 20. So that'll be really helpful for your graphing, because as soon as you get your turning point, you can do a whole bunch of things straight from there. And this is what turning point form is. We have x minus something all squared minus 20. So it's halfway through completing the square. This is why completing the square is also really powerful, because it allows you to jump straight to some graphing stuff. Okay, so we can stop at that. Instead of finishing completing the square and writing it as 2 factors in brackets, okay, we can actually just solve it for x. Okay, this is the one new thing today. Okay, once we get to turning point form, instead of finishing completing the square, we can just solve it for x. Okay, and we do that, negative 20, we can add 20 to both sides. That cancels, and now we're up to this stage. We take the square root of both sides, remembering if we take the square root of something, we have a positive or negative solution. Okay, because if we had the square root of 25, that's the same. We can have the same as, that gives us solutions of either 5 times 5 equals 25, or negative 5 times negative 5 equals positive 25. So we have a positive or negative solution. We can't forget that. Okay. Simplify the surd is what's going on here in this step. And then we take the plus 1, take this negative 1, do the opposite. So plus 1, 1, that cancels, and we get this solution here, which is the exact same as on the previous slide. Okay, we had 1 plus 2 root 5, or 1 minus 2 root 5. Okay, 1 plus 2 root 5, or subtract 2 root 5. Now again, you can use either method unless it says use the null factor law. If it doesn't say you have to use the null factor law, you can use this method as well, which is quite handy because it avoids, it's about the same in level of steps, but turning point form is handy for graphing. Okay, and sometimes it will be quick. Okay, so let's solve these by first completing the square. It doesn't say we have to use null factor law, so we're going to use this new method that we've looked at. So let's x squared plus 4x. Now half 4 is 2, then square it. So 4 minus 4 minus 14 equals 0. Get x plus 2 all squared. 18 equals to 0. Now I'm not going to use the null factor law. I'm not going to finish. Okay, I've got difference of perfect squares. I've completed the square here, but I'm not going to go into 2 factors in brackets. I'm just going to go x plus 2 all squared equals 18. X plus 2 is equal to the plus minus square root of 18. Okay. Now the square root of 18 is the same as the root of 9 times 2, which is equal to 3 root 2. We get x plus 2 equals plus or minus 3 root 2. X is equal to plus or minus 3 root 2 minus 2. There we go. Okay, let's try B. So we get x plus 3 x, 3x. Now half 3 will be 3 on 2, and then square it, so we get 3 on 2 squared. That gives us 9 on 4, so we get plus 9 on 4. Take away 9 on 4, plus 1. Zero. So we get x plus 3 on 2 all squared. Negative 9 on 4 plus 1. So 1 is the same as 4 on 4, so that's going to give us negative 5 on 4. It's equal to 0. Okay. And just quickly, it hasn't come up in this case, so I'm going to grab a red pen. But if it just so happened that this is a positive, and then we take it over to the other side, and this is our what if, we would end up with an equals negative 5 on 4. Now we can't take the square root of a negative number. Okay? So that would tell you, if you got to this point, if we had a positive here, just like when completing the square, okay, if we have a positive here at the end, if you try and take it aside, we get to this point where we can't go any further. It has no solutions. Now, technically, it's called something having no real solutions. There's imaginary numbers that we can use to make this work, but that's a much later topic. So all we have to go with at the moment is if we have an addition here instead of a negative, okay, if we had an addition there, okay, you'll get no solutions, which is completely fine. Which all it's really telling you is that the parabola doesn't cross the x-intercept. But let's continue with this. We get x plus 3 on 2 squared equals 5 on 4. We get x plus 3 on 2 is equal to the plus or minus square root of 5 on 4, which, okay, square root of 5 on 4 is equal to the square root of 5 on 2 times 2, so it's equal to the square root of 5 on regular 2 equals plus or minus square root of 5 on 2. Okay, so x is equal to plus or minus, that's right, on 2 minus 3 on 2. And if you notice, we have a subtraction of fractions with the same denominator, so we can write this as all on 2 plus or minus 5 plus 3. And that is a solution. Okay, and both these times we didn't use the null factor law. You can use the null factor law, but this time we haven't. Okay. Now, a little bit of further understanding. This isn't required, but it gives you an idea of how we actually can make a whole bunch of these problems. Is instead we can start with the solutions, okay, that would get from perfect squares. In this case, we have the okay, x plus 5, our x plus 5, and then we have an add a term and a subtract a term. So this was the solutions we'd get from a perfect square, and working backwards we can get to the original by expanding. So expanding, we're going to have, oh, it's going to be fun. This is going to take a lot of work. Okay, so let's start with our first term. So we get x squared plus 5x 2 minus 1x 2. So that's that first term multiplied out. Now we'll do the middle term. So we get plus 5 2 plus 5. That will be 2 squared minus 5 root 21 on 4. We need some more space here. Plus root 21 x plus 5 root 21 4 minus root 21 2 squared. Okay, that is it expanded. Right, okay, let's group some like terms. What do I got? A 5x 2. That. We'll go with that for now. Try and do everything in one step. So 5x on 2 plus 5 on 10 is going to give us 5x. 21 root x. That's a subtract, that's an add. That's actually going to cancel. That's the same over here. This is a subtract, that's an add. So that's going to cancel. What do we have left? We have plus 5 on 2 squared minus root 21 on 2 squared x squared plus 5x. 5 on 2, that will be the same as 25 4 minus 21 4, because the square root 21 all squared just turns into 21. Is this x squared plus 5x plus 4 on 4 is equal to x squared plus 5x plus 1. There we go. Okay. Now, if you tried to factorize this, you would realize that you can't do it via inspection. So you would use completing the square and you would end up all the way back with the thing that we started with at the start. Okay. So this is how we can generate problems. Okay, so example 3 is use the concept from part A to create your own quadratic trinomial by first starting with the factorized form in brackets. It can be as crazy as you like, but you must be in the form of difference of perfect squares. So what does that mean? Well, you have your main brackets, and within it you're going to have something that's the same. So you're going to have x plus a, you're going to have x plus a, and then you're going to have plus b minus b. Okay. Now, a can be whatever you like, b can be whatever you like. You can put anything, you can put fractions, you can put surds, whatever you like. And then if you expand it exactly the same as we did here, okay, you'll get to a quadratic. Now, depending on the values of a and b that you pick, it can get a bit messy. You can have some terrible fractions or terrible surds, but I'll leave that for you to play. This whole point is for you to play. Okay? And that is it for exercise 5H. Like always, if you have any questions, put them in the comments below or on the Class Edmodo page. Thank you very much.